C++11 introduced range-based for loops which allow for easy iteration over container objects, similar to for each constructs in other languages. So here in the code here we have a container. We have a map containing a mapping of integers to a vector, and the vector itself contains pairs of ints. And we can see some code here to iterate over the vector, the pair in the vector. And we can see that the code is slightly complicated. It's not easy to instantly see what's going on. We can assume that we're iterating over the container, but in actual fact we actually have to go in and read the code to see what's going on. So let's analyze the code and see what QAC++ says about the code. So we can see we have some issues with the code. We're hiding a similar kind of declaration. So if we use the identify end in the inner loop as well as the outer loop, and this can potentially cause confusion and problems, and the code itself isn't particularly readable. So there's a couple of ways we can improve the code. The first thing we can do is we can use the auto keyword in QAC in C++11 to let the compiler determine the type of the iterator for us. And we can see that code here. We've used the keyword auto rather than declaring the type of the iterator, and the compiler will now work that out for us. So we can analyze the code again. And we still have the same problem with redeclaring end, but it's a little bit easier now to see where the issue is. But now we can go a little bit further and use the range-based for syntax to completely remove the boilerplate code there for iterating over the container. So here's the final code. We have used auto, and we've used the colon and then the container to specify the container we wish to iterate over, and that's all we need to do. QAC++ has passed the code, and it's telling us that we're using some syntax that is only available in C++11, and this is useful if we want to ensure that our code will compile on a pre-C++11 compiler. Obviously if we're using a C++11 compiler, we can turn these messages off and QAC++ will just pass the constructs silently. C++11 allows you to define suffixes to use with literals to force the literal to be of a certain type. It's similar to the built-in suffixes. For example, UL indicates that a literal is of type unsigned long. User-defined literals allow you to define a type for your literal. So we have some code here where we have a function called setThruster, which is going to take a double, and this is going to set the speed of a spacecraft descending on the Martian surface. And the trouble with this code is one particular team has developed the code for setThruster, and another team is using the code, and there's a mismatch between the units they're passing in. The people who develop setThruster expect the descent speed to be in meters per second, but the people using the function are passing in miles per hour. And here where they pass in 50, actually 50 meters per second is 111 miles per hour, and this sets the speed of the spacecraft too high, and the spacecraft will crash on the lunar surface. So we can try and make this code a little bit safer by introducing a type for our parameter to the setThruster function. So here we've done that now. We're now taking a type called speed, and that contains the actual speed we want to set. But we haven't really gained anything here because we're still using the same literal 50, and that could be anything: 50 miles per hour, 50 meters per second, 50 kilometers per hour. So we still don't really know, and we've also now got a different problem. And if we analyze the code, we find there's an error. We can no longer pass in a literal to this function because we're expecting a type speed, and there's no conversion available from a literal to a type of speed. So we can take advantage of the user-defined literals in C++11 to create a new suffix to force the type of the literal we're passing to that function. So in the code now, we've now introduced a new suffix _MPS for meters per second, and this uses the C++11 construct operator quotes quotes, and it takes a long double because we have to pass in the longest type that we can, and this is implicitly converted to a double when we instantiate the speed object, but that's okay, and we're just suppressing the narrowing conversion there. So if we now look further down where we're setting our instantiating our object, we can give it a suffix MPS, and our object is okay, and we can pass that into the set thruster speed. And we can also put a suffix on our literal and pass that into the function, and that's okay. But if we try and pass an unsuffixed literal in, we get told that there's no matching functions, so that we can't actually pass in a literal of that particular type of a literal double to this function anymore. We have to use the suffix to specify the type. Now we can take this a little bit further and help the people who are using the function by creating some conversions and allowing them to specify the units with different suffixes. So now we've added some extra suffixes, _mph and _kph, and we've converted them with appropriate conversion factors to convert from miles per hour and kilometers per hour to meters per second. We've also added the plus operator and returning the addition of the two speeds. So this now means we can pass in literals of MPS, MPH and KPH, but we can also mix and match our suffixes and add them together, so that we've got a much more versatile system, which is safer because there's a suffix on each literal to reinforce what the literal is for.